So hello everyone, my name is Prachi and let's start with the video solutions of Brahmastra part test 1. Okay, so in the chemistry section A, question number 51 says that if the density of a solution is 3.12 gram per ml, the mass of 1.5 ml solution in significant figures is. So it has been asked that we have to find out what is the volume, what is the mass, right? We have to find out that what is the mass in significant figures. We have to find out what is the mass. The density is given in the question as 3.12 gram per ml and the volume is also given as 1.5 ml. Okay. We have to find out the mass. That too mass should be in proper significant figures. Okay, so it is easy. We just have to put the formula for density. So we know that density is equals to mass by volume, and we have to find out the volume, which means we have to find out the mass, which means that mass equals to density into volume. Okay, on putting these values in this equation, what we will get? See, density is 3.12, volume is 1.5 ml, and we know that mass equals to volume into density, right? Volume is 1.5 ml and density is 3.12 gram per ml, which means that the mass of the solution is 4.68 gram. Okay. Now the question is we have to put it in proper significant order, right? See, here the density, how many significant figures does the density have? It has 3.12, which means 3 significant figures, and the volume has 1.5, which is 2 significant figures. Okay, so it is the rule of significant figures that the result must be rounded to match the measurement with the fewest significant figures. Okay, so among these two, which has the fewest significant figures? Volume has the fewest significant figures, right, which is 2 significant figures. Therefore, the final answer should be contain 2 significant figures. Okay, it should contain only 2 significant figures. So what will be the answer? The answer will be 4.7. Okay, it has 2 significant figures. Therefore, option number 1 will be the correct answer here. So now let's move on to question number 52. Question number 52 says, which one of the following has the minimum number of atoms? Which has the minimum number of atoms? The options are 1 gram of Mg solid, atomic mass is given of magnesium, which is 24, 1 gram of O2 gaseous, atomic mass of oxygen is given as 16, 1 gram of lithium, atomic mass of lithium is given as 7, and 1 gram of silver. Okay, and atomic mass of silver is given as 108. So we have to find out that among these four, which will contain the minimum number of atoms, right? Okay, so we know that each atom contains 6.022 into 10 to the power 23 particles. Okay, and it is the constant that provides the, okay, what is it? It is Avogadro's number, and it provides the direct relationship between the number of particles and the amount of substance. So we know that number of particles, what is the formula for number of particles? It's moles into Avogadro number. Okay, by this formula we can find out that which of these has the minimum number of atoms. So for number of magnesium atoms we will find out the number of moles. The moles is 1 by 24 into Na. Na is the Avogadro number, we can write it as Na also. Okay. Now number of oxygen atom is number of moles into Na, and here it is 2 Na. Why 2? Because 2 oxygen atoms are there na in a molecule O2, therefore 2 is multiplied here, which is 1 by 32 into Na. Number of lithium atom is 1 by 7 into Na, and number of silver atoms is 1 by 108 into Na. So among these four, which will have the minimum number? Ag will have the minimum number of atoms, right? Ag is the smallest here, therefore Ag will have the minimum number of atoms. Okay, it will have the smallest number of atoms. So option number 4 is the correct option. You can also refer to the taggings here, right? See here the taggings are given. It is from basic concepts of chemistry and its subtopic is mole concept or molar masses. Next, it is a fill in the blank type question. We have to find out the correct answer. Okay, and its difficulty level we can also refer as it is a difficult. It poses a difficulty level of 2, and it is NCERT concept based questions and DPYQ questions. DPYQ, which is the derived previous year questions. Okay. Now we can also refer to this diagram. Okay, this diagram, grams of substance. It is very easy. You can follow this for number of questions. Okay, grams of substance. If we divide it by molar mass, we will get the moles of the substance, and if we multiply it by Avogadro number, we will get the number of atoms or molecules. Similarly, if we divide the number of atoms or molecules by Avogadro number, we will get the moles of substance, and if we multiply it by molar mass, we will get the gram of substance. Okay, so this type of flow chart is very important for your question. Okay, is very important for your concept point of view. From this, you can find out the solution for very different types of questions, right? Now question number 53. Question number 53 says the number of moles of nitrogen, the number of moles of nitrogen molecules required to produce 50 moles of ammonia through Haber's process is. Okay, so we have to find out the number of moles that nitrogen molecule will require to produce 50 moles of ammonia through Haber's process. So first of all, let's see what is Haber's process. We should have known till now that what is the formula for what is the equation for Haber's process. Okay, so the Haber's process equation is N2 gaseous plus 3H2 gaseous reversible to NH3 gaseous. This is the formula for Haber's process. Okay, or you can say equation for Haber's process. Now let's see. 50 moles is needed to produce. 50 moles is needed to produce. 50 moles of ammonia is needed to produce. How many moles of ammonia? How many moles of nitrogen? Okay. So here we can equate it as follows: 2 moles of NH3 because here 2 moles are there. Okay. So NH3 will have 2 moles, and if 2 moles of ammonia are reacting to form 1 mole of nitrogen, or you can say 1 mole of nitrogen is required to form 2 moles of ammonia. So how many moles of NH3? 20 moles of NH3 is given in the question. Okay, 20 moles of NH3 will require 50 moles needs to be produced. Okay, so here it is 50. 50 moles of NH3 will be required to produce 25 moles of ammonia, right? So 1 into 50 by 2, which is 25 moles. So 25 moles of ammonia will be produced in this case. Okay. Similarly, you can read the detailed explanation also. It will provide you the explanation for the Haber's process. Okay, Haber's process, it is also known as Haber-Bosch process, and it is an industrial method for synthesizing ammonia from nitrogen and hydrogen. Its temperature is 400 to 500 degrees Celsius and its pressure is 150 to 250 atmospheres. Catalyst is also needed. Okay, so you can read it from here. Question number 54. Question number 54. What does question number 54 says? An organic compound contains 87% by weight carbon and remaining percentage of hydrogen. The right option for the empirical formula in this compound is. Okay, so what is the right formula for the what is the right formula? Right empirical formula for this compound? Okay. So element is given, it is carbon and hydrogen. We have to find out the empirical formula of carbon and hydrogen. Mass percentage of carbon is given as 87% and of hydrogen is given as 13%. Okay. So number of moles, we can find out the number of moles. What is the formula for number of moles? So number of moles is mass percent by atomic mass. Okay. By this formula, we can find out the number of moles. So mass percent of carbon is 87 and atomic mass of carbon is 12. So we will get the number of moles as 7.25. Similarly, we can find out the mass number of moles of hydrogen. So mass percentage of hydrogen is 13 and its atomic number is 1. So number of moles of hydrogen is 13. Mole ratio. Now we have to find out the mole ratio. So mole ratio is the number of moles by smallest mole. Okay. Mole ratio formula is number of moles divided by smallest mole. Okay. Number of moles which means it is 13. Okay. By 7.25. 13 is for hydrogen and 7.25 is of carbon. So it is 2. Similarly, for hydrogen also we will get 13 by 7.25. It is 2. Okay. So now what will be the molecular formula? C2H2. So C2H2 will be the molecular formula. Option number 1. Option number 1 will be the correct option here. So if you want, you can go for detailed explanation also. Atomic mass of carbon is 12.101 and atomic mass of hydrogen is 1.008. Now we have to convert the percentage. Okay, you can refer to this also. It is also uh, in the detailed version. Next is, what will be the molarity of the solution? Question number 55. What will be the molality? Molality, it is small m. Molality of the solution if its mole fraction is 0.2. Okay, mole fraction is given as 0.2, and what will be its molality? Molality we have to find out, which means small m we have to find out. Okay, so we know that xb is 0.2. So what is xb? It is moles of solute B. Okay, it is moles of solute B. So if xb is 0.2, so what will be xa? It will be 1 minus 0.2, which is 0.8, right? And we know that the formula for molality is number of moles of B into 1000 divided by number of moles of A into Ma. Okay, Ma is the molecular mass. Ma is the molecular mass. So by this we can put the values. Xb here is 0.2 into 1000 divided by Xa we have find out 0.8 and 18. What will the molarity of the solution? Solution we will consider it as water. Okay, so Ma of water is 18. So we will get the molality. It is small m. Molality is 13.88 molal. Okay, yeah. 13.88 molar, which means option number 1. Option number 1 is the correct option. So now next question number 56. What does question number 56 says? 3.01 into 10 to the power 21 molecules of glucose are present in 150 ml of its solution. What is the concentration of the solution? Okay. So 3.01 into 10 to the power 21 molecules of glucose, which means moles of glucose. Here it will be glucose. Moles of glucose is given. Is given. So what will be the moles, number of moles? How we will find out the number of moles? So number of moles will be moles of glucose, or you can say, right? Moles of glucose. Moles of glucose will be number of moles of glucose divided by total number of molecules. Okay, total number of molecules. So it is given in the question that 3.01 into 10 to the power 21 moles. So number of moles of glucose will be 3.01 into 10 to the power 21, and total number of molecules will be its Avogadro number, that is 10 to 6.02 into 10 to the power minus 23, which comes out to be 0.5 into 10 to the power minus 3. Okay. Now we will find out the molarity. So molarity we can find out, it is 0.5 into 10 to the power minus 3 by 100. Okay, one thing in the question it should be 100, not 150. Okay, in the question there is a mistake, it will be 100 ml of its solution. So volume will be 100. So in this case we will find out the molarity. Molarity will be, what will be the formula of molarity? Molarity is number of moles of solute by volume of solution in liter. So number of moles of solution into volume of solution in liter, we will find out the value of molarity as 0.05 into 10 to into, sorry, 0.005 molar. Okay, which means 0.005. Option number 1. Question number 56 as first as the correct option. Next is question number 57. In question number 57, in the following question, a statement of assertion followed by a statement of reason is given. So this is an assertion reason type question. In assertion, it is given the empirical mass of ethene is half of its molecular mass. Okay, the empirical mass of ethene is half of its molecular mass. So we will find out that whether the statement is correct or incorrect. So we know that the molecular formula is N into its empirical formula. And if we find out N, then what will be the equation? It will be molecular mass by empirical formula mass. So empirical formula of ethene, we know that what it is? It is C2H2, CH2, CH2, and in the middle it is double bond. And empirical formula mass will come out to be 14 AMU. Empirical formula mass of C2H2 is 14 AMU. Okay, and it is half, which is half the molecular mass of ethene. Empirical formula is 14 and which is half the molecular mass of ethene. Ethene has a molecular mass of what? 28. So it is half the molecular mass of ethene, right? So assertion given in the question is correct. Let's look upon the reason now. The reason is given as the empirical formula represents the simplest whole number ratio of various atoms present in the compound. Okay, this is the reason. So the empirical formula represents the simplest whole number ratio of elements in the compound. Yes, this statement is totally correct. If we consider ethene, the empirical formula is CH2, indicating that every carbon atom there is two hydrogen atom, right? For CH2, every carbon atom has two hydrogen atoms. So this will be the empirical formula. CH2 will be the empirical formula whole N, and it is half its molecular mass. Okay, if we multiply it by 2, then it will be its molecular mass. So option, the reason is also correct. The empirical formula is the simplest whole number ratio. Okay, we know that, so it is also correct. Option number 1 is the correct answer. Question number 58. Let's move on to question number 58. The number of urea molecules present in 200 ml of 1 molar aqueous solution of urea is, number of urea molecules present in 200 ml of, so volume is given as 200 ml, and of 1 molar aqueous solution of urea. 1 molar, which means molarity. Molarity is given as 1 molar. Okay, we have to find out the number of urea molecules. Whenever you start a question or start solving a question, just write first what is given in the question. If you write everything that is given in the question now, so you can easily find out that what we have to find out and how the question can be solved. You can look upon it, you can think upon it. Okay, so first of all, write what is given in the question first. Okay. So in question number 58, the number of urea molecules, okay, the molarity of the solution is 1 molar, okay, it is given in the question, which means that 1 mole of urea is present in 1 liter of solution. Okay, so we know that if 1 molarity, what is molality? Molarity, what is molarity? It is number of moles of solute by volume of solution, right? So if 1 mole of urea is there, so it will be dissolved in 1 liter of solution. Okay, so we will find out that molarity is 1, and number of moles of solute we don't know, we have to find out. Volume is given as 200. So what will be the moles of solute? It will be 1 into 0.2, which is 0.2. So 1 mole of urea has 6.022 to 20 to the power 23. So how much moles of urea is there in 0.2? We have to just multiply it by number of moles of urea, which comes out to be 1.2 into 10 to the power 23. Okay, option number 4, 1.2 into 20 to the power 23. This will be the correct option. Okay. Next question is question number 59. Question number 59 says the molarity of the solution obtained after mixing 9 gram of glucose in its 250 ml solution. Okay, molarity of the solution. Molarity is capital M, we have to find out after mixing 9 gram of glucose. Okay, mass is given as 9 gram and volume is given as 250 ml. Okay, this is given and we have to find out the molarity. So moles of glucose, we know that what is the mole of glucose? It is given mass by molecular mass. Okay, given mass by molecular mass. Given mass is 9 and molecular mass of glucose is 180, which comes out to be 0.05 moles. What is volume in liter? Volume in liter 250 ml, it is given in milliliter. We have to convert it into liter, so it will be 0.25 liter. Now molarity, we can easily find out the molarity. It is the number of moles of glucose, which we have to find out as okay, number of moles of glucose by volume. Okay, number of moles of glucose, it is 9 into 180. 9 into 180 we can easily write as, which we have find out, 0.05 moles divided by 0.25. Okay, it is given in the expanded form. We can easily write it in the compact form also, as we have already find out the values of these two. So these two, and what will be the answer? It will be 0.2 molar, right? 0.2 molar. So option first, 0.2 molar will be the correct option in this case. Okay. Next is question number 60. A solution contains 64 gram of methyl alcohol and 36 gram of H2O. The mole fraction of methyl alcohol in the solution is. Okay, solution contains 64 gram of methyl alcohol. So mass is given as 64 gram of methyl alcohol, which means CH3OH, and 36 gram of H2O, water. What will be the mole fraction of methyl alcohol? We have to find out the mole fraction of methyl alcohol in the solution. Okay. So now, what is the mole fraction of methyl alcohol? It will be the number of moles of methyl alcohol by number of moles of methyl alcohol plus number of moles of water. Okay. Remember the formula. What is the mole fraction? It is the number of moles of A divided by number of moles of A plus number of moles of B, or you can say that total number of moles. Okay. So number of moles of A. How we can calculate the number of moles? Number of moles can be calculated by given mass by molecular mass. Okay. So given mass of A, or you can say number of moles of CH3OH. Given mass is 64 and its molecular mass is 32, which comes out to be, you can calculate it, number of moles of water. Number of moles of water is how much? Given it is 36 and its molecular mass is 18. Okay. So now easily we can calculate this by this formula. Number of moles of CH3OH is 64 by 32 by total number of moles, 64 by 32 divided by plus 36 by 18, which will be 0.5. Okay. So 0.5 will be the correct option for question number 60. Okay. Now next is question number 61. Question number 61 says the density of 1 molar solution of a compound X is 1.5 gram per ml. Density of 1 molar. So molarity is given as 1 molar of compound X. Density is given as 1.5 gram per ml. The correct option for molality, we have to find out the small m. Okay, capital M is already given and we have to find out the small m. So what is the formula? What is the relation between small m, molality and density? Okay, so this is the formula. Molality equals to 1000 m divided by 1000 into density minus m into it is molecular mass into moles of solute, mass of solute. Okay, 1000 m. M is given as 1 molar. M here is molarity. Okay, m. 1000 into 1 by 5, 1.5. Density is 1.5 already given in the question. Molarity is 1 and mass of solute. Mass of solute is given as 100. See, molar mass of solute is given as 100. Okay. So, what we upon solving this, what we will get? We will get 0.714 molal. Okay, 0.714 molal is the correct option. Next, move on to question number 62. What does question number 62 says? Reaction of calcium with water is represented by the equation. The reaction is given here. What volume of hydrogen measured at STP would be liberated when 8 grams of calcium completely reacts with water? And atomic mass of calcium is given as 40. Reaction of calcium with water is represented by this equation. Okay, the equation is given here. Now, according to the stoichiometry of the reaction, 1 mole of calcium produces 1 mole of hydrogen. Okay, here we know that 1 mole of calcium is produced 1 mole of hydrogen. So, 0.2 moles of calcium will produce 0.2 moles of hydrogen gas. Yeah. So, how this 0.2 moles comes? Let's see. From the balanced chemical equation, okay, 2 moles is produced. We know that. Now, number of moles of calcium. Number of moles of calcium. So here 0.2 is the number of moles of calcium, okay, which is mass of calcium by molar mass of calcium. Mass of calcium, what is mass of calcium here? It is 8 grams is given in the question. Mass of calcium is given in the question as 8 grams and atomic mass is also given as 40 gram, okay, which comes out to be 0.2 moles. 0.2 moles. Now what we have to do, we need to use the ideal gas law. We will use the ideal gas law, which is PV is equals to nRT. Now we have to find out the volume. What is asked in the question? What volume of hydrogen? So we have to find out the volume now. So what volume of hydrogen? Volume, this equation becomes nRT by P. N is the number of moles. Number of moles we have find out as 0.2 and R is the gas constant. N is the number of moles, N is the number of moles, R is the gas constant and T is the temperature. What is P? P is the pressure. Okay. Sorry for the disturbance, guys. R is the gas constant, which is 0.0821 into temperature. Temperature is, we will consider the room temperature only, which is 273. And pressure is 1 atm. Okay. STP means standard temperature and pressure. Standard temperature and pressure, its temperature will be 273 Kelvin and pressure will be 1 atm. Okay. So this only we will consider at STP. So like this. Okay. So what will be the volume of? What will be the volume? Volume will be 4.495 liter. Okay. So it is in liter and see what are the options given here? The options given here are in centimeter cube. Options are in centimeter cube. So on converting centimeter cube, what we have to do? We will multiply it by 1000 centimeter cube, right? So for volume, we will get 4496 centimeter cube. 4496 centimeter cube. So option number 1. 4496, or you can say it is nearly equal to 4480. Okay. Next is question number 63. Question number 63 says mass of calcium carbonate required to react with 400 ml of 1.5 molar HCl solution is. Mass of calcium carbonate required to react with volume is given as 400 ml. and molarity. Molarity is given as 1.5 molar. Okay, and we have been asked the mass. What is the mass? So we know that the formula for molarity is moles of solute by total volume into 1000. Molarity is given as 1.5, we know. Moles of solution we have to find out. Volume is given as 400 ml. So from this we will find out the moles of solute, which comes out to be 0.6. Now mass of 0.6 moles, what will be the mass of 0.6 moles? It is moles into molecular mass. So easily we can find out the mass of 0.6 moles, which is 60 gram. Okay, 660 gram we will find out, right? So if you are confused here that how we have find out the mass of okay. So we know that na moles. What is moles? Moles formula is given mass by molecular mass. This we have to find out. So given mass, what will be the given mass now? Moles into molecular mass, right? So from this formula we will find out the mass of 0.6, which is 60 gram, option number 4. Next is question number 64. Question number 64 says volume of CO2 obtained at STP by burning 32 gram of CH4 with 64 gram of oxygen is. Okay, volume of CO2, we have to find out the volume of CO2. Burning of mass is 32 gram of CH4 and mass, it is mass of CH4, and next mass of oxygen is also given as 64 gram. Okay, we have to find out the volume. So we know that what is the equation for the burning of methane. So the burning of methane follows this equation: CH4 plus 2O2 will give CO2 plus 2H2O. Okay, now moles of CH4. What is the moles of CH4? Given mass by molar mass. Given mass is 32 and molar mass is 16. So which means 2 moles of CH4. Now 1 mole of CH4 contains this much liter of. Okay, at STP it is given. So at STP, if we consider volume, it is 22.4 liter. Okay, so 1 mole of CH4, we know that it contains 22.4 liters. So 2 moles of CH4 will contain 1 mole of CH2, and 1 mole of CH4 will contains half mole of CH2. Now, what will 1 mole of carbon dioxide contains? It will contain 22 by 2 equals to 11.2 liter, 11.2 liter, option number 2. 11.2 liter volume will be required, okay, to burn the methane in oxygen. Next is question number 65. How many grams of concentrated nitric acid solution should be used to prepare 800 ml of 1.6 molar HNO3? How many grams, which means mass? Mass we have to find out of concentrated nitric acid is used to produce. Volume is 800 ml of 1.6 molar. Molarity is 1.6, right? The concentrated HNO3 is 70% weight by weight, which means that weight by weight percent is given as 70. Okay. Now, we know that what is the formula for molarity? It is moles of solute by total volume into 1000. Moles of solute we will find out as molarity is given 0.8, 1.6, and total volume is 0.8. Yeah, 0.8, it is in liter. It is given here is in milliliter, so it will be 0.8 liter. Okay, molarity is always is calculated in liter, right? So moles of solute we will get as 1.28. Now, mass of 1.28 moles, what will be the mass? It is moles into molecular mass, which means 80.5 gram, and mass of HNO3 in 70% concentrated acid is weight by weight, it is given as 70%, right? So it will be mass divided by concentration into 100, which will be 115.2 gram, 115.2 gram, which is option number 2. Okay. Question number 66. Next is question number 66. The total number of electrons present in 26 gram of Al plus 3 ions. Total number of electrons present in 27 gram. Mass is 27 gram and total number of ions it is asking. Total number of ions. What is the total number of ions? So moles, we know that it is given mass by molar mass, which is 27 by 27, which means 1 mole of aluminium. Okay, so 1 mole of Al plus 3 has how much electrons? It will have 10 electrons, right? 10 electrons, you can calculate this. So 1 mole of aluminium will have 1 Na, 1 Avogadro number, one number of moles you can say. So how much will 10 electrons have? It will have 10 Na now. 1 mole of aluminium will have 1 Na, then 10 electrons will have 10 Na. So simply the answer would be option number 2. Next is question number 67. If the density of 4 molar solution of NaOH is 1.25 gram per ml, then the weight by weight percentage of NaOH in the solution is. Density is given as density is given as 1.25 gram per ml, and molarity is given as 4 molar, right? And we have to find out the weight by weight percent. What will be the weight by weight percent? So we know that weight by weight percent is mass of solute by mass of solution into 100, which is 12.8%. 12.8 mass of solution in okay. So let's do it in a detailed way. Okay, molar mass of NaOH. Molar mass, how we can find out the molar mass of NaOH? It is molar mass of sodium plus molar mass of oxygen plus molar mass of hydrogen, which comes out to be 40 gram per mole. Now let us calculate the mass of NaOH present in 1 liter of solution. Okay, mass of NaOH, which is mole into molar mass. Mole is 4 and molar mass is 40. Mass of NaOH is 160 gram. Now density. What is density? Density is the mass of solution by volume of solution. We know that density is equals to mass by volume. So density is given as 1.25 and mass we will calculate, and the volume is 1000 ml. So mass of the solution comes out to be 1250 gram. Now similarly we can find out the percentage weight by weight. Mass of solute we have found as 160 and mass of solution is 1250. Okay, into 100 we will do, and it comes out to be 12.8 gram. 12.8 gram, option number 3. Option number 3 is the correct option. Okay. Next is question number 68. Question number 68 says that 81.4 gram of sample of ethyl alcohol contains 0.002 gram of water. The amount of pure ethyl alcohol to the proper number of significant figures. Okay, significant figures is an important topic, and it is very easy also. It just requires you to do some calculations, and in the final answer you just have to find out that what is the right number of significant figures you will get. Okay, so here see 81.4 gram sample of ethyl alcohol. So weight of ethyl alcohol is given as 81.4 gram, contains 0.002 gram of water. So weight of water, it is 0.002 gram. Amount of pure ethyl alcohol to the proper number of amount of pure ethyl alcohol we have to calculate. Okay, so what is pure ethyl alcohol? It is 81.4 minus 0.002. So simply we just have to minus both the numbers. Okay, simply we just have to minus both the numbers. So how many significant figures are present here? How many significant figures are present here? Least number of significant figures we have to find out now. So 81.4, 1, 2, 3. Here it is 3 significant figures, and it is 1, 2, 3. It is also 3 significant figures. So we will find out the correct answer as 81.398. 81.398. Okay, so this is the correct option. Option number 1 is the correct option. Next is question number 69. Let's use a different pen color. Red and green is okay. So question number 69. Which of the following rules regarding the significant figures and their calculation is correct? See, one more question is of significant figures, I'm telling you that this significant figure topic is very important, and almost one year or the other the question from significant figures comes definitely. Okay, so keep a good hold in this topic. Now, first statement is the result of an addition or subtraction is reported to the same number of decimal places as present in number with least decimal places. Result of multiplication or division should have same number of significant figures as present in most precise figures. Result of multiplication or division should be rounded off to the same number of significant figures as present in least precise figures, and the non-significant figures in the measurements are rounded off. Okay, so these four options are there. Let's read the explanation. In multiplication and division, the result should be reported with the same number of significant figures as the factor with the least number of significant figures. Okay. So it is asking that which is incorrect. One more thing. Okay. If you are solving this correct incorrect type questions now, always highlight or circle or underline anything you can do the option which is here. It is asking for incorrect now. So if you are in a hurry, what you will do now, you will just think that the question asks for a correct option. So in that case what you will do, you will just, the first one is correct only, so you will just tick the first one which is the correct option, and the whole question comes out to be zero. Okay, the whole question is wrong. So just first whenever you are reading the question, if you see the word like this incorrect or correct, just first highlight this one and then try to solve the question. Okay. So here see, in multiplication and division type question, the result are to be reported with the same number of significant figure as the factor with the least number of significant figure and not the precise figure. So it is given, it is present in the most precise figure. So this is the incorrect option. Okay, this is the incorrect option because least number of significant should be there, not the most precise significant figure. Next is question number 70. Which of the following statement is correct about the reaction given below? So here it is a reaction given below. Fe plus 3O2 will give 2 Fe2O3. So let's read the statements. Total mass of iron and total mass of oxygen in reactants equals to total mass of iron and oxygen in the product. Therefore, the following law of conservation of mass. Okay, here we are being asked the laws of chemical proportion. Okay, it is the question from laws of chemical proportion. So here this equation is given and you have to find out that which is the correct law which is being followed here. Next is total mass of reactants equals to total mass of products. Therefore, the law of multiple proportion is followed. Amount of Fe2O3 can be increased by taking any one of the reactants in the excess. Amount of Fe2O3 produced will decrease in the amount of any one of the reactants is taken in excess. Okay. So now the amount of Fe2O3 cannot be increased by either reactants in excess. Okay. So the amount of Fe2O3 cannot be increased, which means that the reaction is balanced with a fixed stoichiometry. So changing the amount of reaction will not change the amount of products. Okay, so what will this follow? What will this statement follow? Next, the amount of Fe2O3 produced will not decrease if either the reactant is taken in excess. Okay, it will not increase or it will not decrease, which means that it will follow the law of conservation of mass. Okay, law of conservation of mass is followed here, which means that the total product remains, the total number of products remain conserved. Okay, if we increase the reactant or if we increase the product, there would not be any change in the reaction. Next is question number 71. The law of definite proportion is not applicable to nitrogen oxide. Nitrogen oxide is NO. Okay, because law of chemical proportion, law of definite proportion is not applicable to nitrogen oxide. Why? Why it is so? Because equivalent weight of nitrogen differs to different oxides of nitrogen. Nitrogen has different types of oxide. It is NO, it is NO2, it is NO3, it is N2O5 and whatnot. Okay, it has many number of oxides. So its equivalent weight varies. Okay, when nitrogen and oxygen combine, different oxides of nitrogen are obtained which contain different composition of nitrogen and oxygen. Yeah, this is true. And different oxides of nitrogen exhibit law of multiple proportion rather than law of constant proportion. Okay, so it follows the law of multiple proportion and not definite proportion. Because why? Because nitrogen weight is equivalent weight is variable. Option number 3 will be the correct option. Next question is match the column 1 with column 2. Okay, it is a matching type question. Mass of hydrogen produced when 0.5 mole of zinc reacts with excess of HCl. Uh, okay, we have to find out this. So let's solve one by one the question. Mass of H2 produced when 0.5 moles of zinc reacts with excess of HCl. Okay, so this is the reaction. Zn plus 2HCl will give ZnCl2 plus H2. So reaction between zinc and HCl produces hydrogen among the following equation. Okay, yeah. So 1 mole of zinc will produce 2 gram of hydrogen and 0.5 mole of zinc will produce 1 gram of hydrogen, which means that C70H22, this will be the okay, this one is the first one. This one is for first. Okay, 1 mole of zinc produce 2 gram of hydrogen and 0.5 mole of zinc will produce 1 gram of hydrogen, which means that option A, question A will have the option 4. 4 will as the correct option. Mass of hydrogen will be 1 gram. So for A it will be 4. So this is incorrect, this is incorrect. From these two we have to find out. Mass of all atoms of compounds with formula C70H22. Mass of, what will be the mass? We simply have to find out the molar mass here. So what will be the molar mass? It's 862 and mass of atoms comes out to be 862 by Avogadro number, which is 1.43 into 10 to the power 21 minus 21 gram, which means B has 2 as the correct option. Okay, 3 as the, okay, so 3 is both is in both. Next is number of molecules in 35.5 gram of Cl2. So 35.5 gram of Cl2 will have 3.01 to 10 to the power 23. So option number C will have option 1 as the correct option. So option 3 is the correct option and option 4 is the incorrect option. Okay. Question number 73. Next is question number 73. For the following reaction, the mass of water produced from 445 gram of C57H110O6 is. This is the reaction given and we have to find out the mass of water produced. Mass of water produced, how we can calculate? This is the equation. The molecular mass we have to find out, which comes out to be 1780 gram. Next, the molecular mass of 110H2O we have to find out, which is 1980 gram. Now, 1.1780 gram of C57H110O6 produced this much gram of water. So how much gram will 445 gram of C57H110O6 will produce? It will produce 495 gram of H2O. So this is the unitary based question. Unitary method you are doing. Na? Unitary method, simply unitary method we have to follow for solving this type of question, which is 495 gram. 495 gram, option number 2. Next question is question number 74. In question number 74, it is given 25 gram of an unknown hydrocarbon upon burning produces 88 gram of CO2 and 9 gram of H2O. This unknown hydrocarbon contains. Now, 25 gram of unknown hydrocarbon upon burning produces 88 gram of CO2 and 9 gram of H2O. Okay, so see, hydrocarbon, we know that it contains carbon and hydrogen. Hydrocarbons, what is hydrocarbon? Which means that the compounds which contain both carbon and hydrogen, right? And which on burning produce carbon dioxide and water vapor. So this is the formula for hydrocarbon, CXHX plus X by Y by 4O2. Okay, it will give XCO2 plus Y by 2 H2O. So this is the general formula that we are using for hydrocarbon. Now we can find out the mass of carbon, which comes out to be 24, and mass of hydrogen, which comes out to be 1 gram. Okay, so now we will get what is the mass of carbon. It is 24 gram and hydrogen it is 1 gram. So option number 3 is the correct option. Question number 75. Let's move on to question number 75. We are halfway there. Okay. Which one of the following is the lightest? Which is the lightest? 0.2 mole of hydrogen gas. So 0.2 moles of hydrogen gas. It is given in mole, it is given in molecules, it is given in gram, and it is given in mole. So first of all, we will uh, arrange all these in one type of unit, okay, so that we can compare it. So first one, moles is given weight by molecular weight. So we will find out the weight of hydrogen, which comes out to be 4 gram. We are converting all in grams, okay. And now 6.02 to 20 to power 23, it will represent 1 mole, which means that weight of N2 will be 2.8 gram. Now weight of silver already given in gram, which is 0.1, and weight of oxygen is 3.2 gram. Okay, so which is the lightest here? It is silver only. Silver only is the lightest here. So third option will be the correct option. Next is question number 76. In compound A, 1 gram of nitrogen unites with 0.57 gram of oxygen. In compound B, 2 gram of nitrogen combines with 2.2 gram of oxygen. And in compound C, 3 gram of nitrogen combines with 5.11 gram of oxygen. These results obeys the which law it is obeying? It is obeying the law of multiple proportion. Law of multiple proportion is obeyed here. Okay. How compound A will compose of 1 gram of N2 plus 0.5 gram of O2. Compound B will have 2 gram plus 2.24 gram. So like this, the ratio of all comes out to be 1 is to 2 is to 3. Okay. So this is multiple proportion. Multiple units are being added. Okay. Next is question number 77. Question number 77 says, consider the following statements. Atoms of hydrogen, oxygen, nitrogen and carbon have identical properties but different mass. Matter is indivisible into atoms which are further indivisible. The ratio of N is to H in NH3 is 1 is to 3 and N is to O in nitric oxide is 2 is to 1. Dalton's atomic theory supports the law of conservation of mass. Which of the following pairs of statement is true about Dalton's atomic theory? Okay, so it is asked the Dalton atomic theory and its statement. So option number 3, which is 3, 2 and 4 are correct. Okay, matter is indivisible into atoms which are further indivisible. Okay, so Dalton has said this statement and also he has said that Dalton's atomic theory support the law of conservation of mass. So these two statements are correct according to Dalton's atomic theory. Next is question number 78. Which of the following reactions is not correct according to law of conservation of mass? So according to law of conservation of mass, option number 2. Option number 2 is not correct. Okay, highlight this point. It is asking for not correct. Let's see why it is not correct. C3H8 plus O2 gives CO2 plus H2O. Okay. C3H8, it is, we know that it is 44 gram and oxygen is 32, CO2 is 44 and H2O, that is mass of reactants is not equals to mass of products. Law of conservation of mass, in law of conservation of mass, now what happens that mass of reactant should be equal to mass of products. In all the others, you can calculate and find out that the mass of products and reactants is equal. But in option number 2, it is not equal. Therefore, it will not follow the law of conservation of mass. Okay. Next is question number 79. In question number 79, Na is the Avogadro number, then number of valence electron is 4.2 gram of nitride ion is. Na is the Avogadro number, then number of valence electrons in 4.2 gram. Mass is given as 4.2 gram of nitride ion. Number of valence electron is asking. So we know that 14 gram of N3 minus ion will give 8 Na valence electrons. Now 4.2 gram, how much it will give? 8 Na by 14 into 4.2, which is 2.4 Na. 2.4 Na is the correct option here. You can read this, you can read the detailed explanation for the theory part. Okay. Question number 80. Question number 80. The right option for the mass of CO2 produced by heating 20 gram of 20% pure limestone is. So it is given CaCO2 at if we heat at 1200 Kelvin, it will give CaO plus CO2. Okay. So to find the mass of CO2, the following step can be followed. Weight of impure limestone, it is given in the question, it is 24 gram, and we have to find out the weight of pure limestone. So we will do 20% of 20 gram. It is given 20%, right? So it will comes out to be 4 gram. So out of 20 gram, 4 gram is only pure. Now we have to find out the number of moles of CaCO3, which is 0.04 moles, and number of moles of carbon dioxide, which is 0.04 also. Okay. So what will be the weight? What will be the mass of CO2? Mass of CO2 will be 0.04 into 44, which is 1.76. 1.76, which is option 1. Option 1 will be the correct option. Next is question number 81. In question number 81, the number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process is. It is also related to Haber's process, right? Number of moles. Okay, so this type of question is also we have solved, only the numbers are changed here. Okay, it is a PYQ, and that is a derived PYQ. So for 20 moles of NH3, 3 into 20 by 2, which is 30 moles. So 30 moles is the correct option. I am not explaining this again. Okay, so this similar type we have done. In question number 82, a compound X contains 32 gram of A, 20 gram of B, and the remaining percentage of C. Then the empirical formula. Okay, so empirical formula again we have to calculate. So A has 32%, B has 20%, and C has 48%. So number of moles will come out to be this, and the number of moles into smallest number. It will simplest whole number we will get as 1 is to 1 is to 3. 1 is to 1 is to 3, which means A, B, C, 3. A, B, C, 3, option number 4 is the correct option. Okay. Next is question number 83. Question number 83 says that what mass of 95% pure CaCO3 will be required to neutralize 50 ml of 0.5 molar HCl solution according to the following equation. This is the equation. Sorry. So this is the equation. We have to find out that what percentage of 95 pure CaCO3 will be required. Okay. Let's see, this is the equation. The number of pure CaCO3 is half the number of moles of HCl. So number of moles of pure CaCO3 will be half, which is 0.5 into moles of HCl. Now moles of HCl is molarity into volume, which comes out to be 0.025. Also, we know that the number of moles of pure CaCO3 is 0.5 into 0.0025, which is 0.00125. And weight of pure calcium carbonate, it comes out to be 1.25 gram. Now percentage of purity we can calculate. Percentage of purity we can calculate by the formula weight of pure CaCO3 by total weight of sample into 100. Given purity is 95%. Given purity is 95%, so upon this we can calculate the weight of the sample, which comes out to be 1.32. Option number 2, 1.32 is the correct option. Now in question number 84. In question number 84, the density of 1 molar solution of a compound X is 1.25 gram per ml. The correct option for the molarity of the solution. Okay. Density is 1.25 gram per ml, and molarity is 1 molar. Correct option for molality. Molality we will find out. This type of question we also have done. By this formula we can calculate. It comes out to be 0.858. 0.858. Okay. What is the number of significant figures in 0.3015 into 10 to the power 3? So 0.3015 into 10 to the power 3, it has 4 significant figures. Okay. So in this case, what we will do, if we multiply, then the number of significant figures in decimal number final will have 4 significant figures. So if 0.3015 is multiplied by 10 to the power 3, then what will be the answer? 3.1 in 301.5. So in this case also it will have 4 significant figures. Option number 3 is the correct option. Okay. Option number 3 is the correct option and not option number 4. Option number 3 is the correct option. Next is question number 86. Okay. 1 second. Yes. Next is question number 86. The highest number of chlorine atom is. So this type of question also we have done. The highest number of chlorine atom, how we can calculate? 35.5 gram of chlorine, molecular mass is 35.5, therefore 35.5 chlorine is approximately equal to 1 mole. Since 1 mole of any element contains this much, okay. So if we calculate 2.27 moles of chlorine at STP. So in this case, what will happen? It will contain this much 1.2124 this much moles of chlorine. Next, 4 mole will contain this much moles of chlorine and 4 unified will contain 1 unified of chlorine. So option 1 will contain the highest number of chlorine only. Question number 87. Question number 87 says 1 mole of oxygen atom weighs 16 gram. The number of atoms in it is equal to how much? Mass of oxygen is given as 2.66 into 10 to the power minus 23 gram. 1 mole of oxygen, 1 mole of oxygen atom weighs 16 gram. Okay. So number of atoms is 1 into 6.22022 to 10 to the power 23. Number of moles of atoms in 1 mole is 6.022 to 10 to the power 23 only. So option number 3. Option number 3 is the correct option for this case. Question number 88. 3 compounds are formed from X and Y. A fixed mass of X combines with a different mass of Y, which is the ratio, which is in the ratio 1:3:5 in compounds A, B and C. Calculates the parts by mass of X which combine with parts 8 parts of mass of X in compound C. It is given that 16 parts of mass of X combined with 42 parts of mass. Okay, this is a long question. Okay, this is a long question and difficulty level should be 3. Upon reading the question only, if you cannot find it, then it is a difficult question. Okay, so let's try solving this. Mass ratio of Y in compound A, B and C, it is given as 1:3:5. Now 16 parts of X combined with 42 parts of Y, and in C 8 parts of X combined with M parts of Y. So we can find it from there. In B 42 parts of Y combined. Okay, so it will be 13. Y value is 16 and C it is M by 8, so it will be 5. So upon calculating this, M comes out to be 35. M comes out to be 35. Okay. So option number 3, 35 parts of mass of Y is the correct option. Question number 89. In question number 89, if 1 gram of potassium hydroxide is treated with 25 ml of 0.50 molar hydrochloric acid solution, the mass of potassium hydroxide left unreacted is equal to. So this is the equation, and 1 mole of KOH reacts with 1 mole of HCl to produce 1 mole of KCl and 1 mole of H2O. So volume is 0.025 liter. Moles of HCl, we will calculate the moles of HCl, which comes out to be 0.0125. Okay. Now, since KOH and HCl react is 1:1 ratio, all HCl will be consumed in the reaction, therefore no HCl is left unreacted. So option number 1 will be the correct option in this case. Question number 90. Carbon has the following 3 isotopes with relative abundances and masses. Okay. So the relative abundance which is in percentage is given and atomic mass is given. On the basis of the above data, the average mass of carbon. What will be the average mass of carbon? Average mass, for average mass we have to calculate the molar mass of carbon, which is sigma isotopic mass into relative abundance by sigma relative abundance. Okay, so we can write it as this: sigma isotopic mass into relative abundance divided by sigma of relative abundance, right? So in this we can find out. Let's try to write here isotopic mass percentage we have calculated 98892 into 12 plus 1.108 into, okay, so you have find out now how we have calculated 1.018 into 13.00335 plus 2 into 10 to the power minus 10 into 14.00317 317. So all this will be divided by relative abundance, which means 98.892 plus 1.108 plus 2 into 10 to the power minus 10. Okay. So like this we can calculate, and on solving this answer comes out to be 12.011 unified. Option number 2. Next is question number 91. Which of the following compounds has the highest oxygen percentage? So for highest oxygen percentage, Na2CO3 will have the highest oxygen percentage. So it will be calculated by molar mass of element into number of element divided by molar mass of compound. So by this formula we can calculate the percentage composition. So Na2CO3 has 57%, KMnO4 will have 40% and NaClO4 will have 60%. So which will have the highest oxygen percentage? Wait a second. Sodium carbonate, Na2CO3. Na2CO3 will have 57%, KMnO4 will have 40%. Sodium chlorate, this one is given. Sodium chlorate is 60%. Okay, calcium oxide. Calcium oxide is not given. For calcium oxide, molar mass of calcium oxide, calcium is 35.5 and oxygen is 16. Okay, so it is 51.5 number of element. How many number of element? It is 2. Okay, and molar mass of compound. Molar mass of compound is okay, oxygen it is asked na. Oxygen here it is 16 into 2 into 51.5. Okay, so you can calculate here. So 16 into 2, 16 into 2 by 15.5. Okay, which means that it is 60% something. Okay, it is something 60%. So, Potassium permanganate. Potassium permanganate will have the least number. Okay. Potassium permanganate will have the highest oxygen percentage. Option number 2. Option number 2 will have the highest oxygen percentage. Which has the highest number of molecules? Which has the highest number of molecules? Which has the highest number of molecules? Question number 92. In question number 92, CH4 will have the highest number of molecules. Okay, how number of molecules is given mass by molar mass. So upon calculating this, CH4 will have the highest number of molecules. Question number 93. In question number 93, what is the molarity of 30 grams of NaCl dissolved in 500 ml of pure water? So, moles of NaCl will be 30 by 58.4, which is 0.513 mole, and mass of water will be 0.500 kg. So, molarity will be 1.026 per mole per kg, 1.026 per mole per kg. Question number 94. The approximate number of atoms in 6.75 gram of H2O is closest to which of the following option? So 18 gram per mole of H2O contains 6.02 to 10 to the power 23. How much 1 gram of H2O will contain? It will be contain 6.02 into divided by 18. So 6.75 will contain into 6.75 we will do, and it will contain 2.25 into 10 to the power 23. Option number 2. Question number 95. In question number 95, 14 gram of hydrogen and 96 gram of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be. What will be the amount of water which is produced in this reaction? Moles of hydrogen is 10 by 2, which is 5, and moles of oxygen is 2. Thus oxygen in the limiting reagent and amount of water produced will be 2 into 2, which is 4 mole. 4 mole is the correct answer. If you are not understanding now with the crisp explanation, then you can go for the detailed explanation as well. You will be provided with the PDF of explanation. Okay. Question number 96. The empirical formula of hydrocarbon contains 20% hydrogen. Is the empirical formula of hydrogen that contains 20% hydrogen. Now, hydrocarbons, we know that it contains carbon and hydrogen. Ratio of number of carbon and hydrogen is 20 is to 1 by 80 is to 1, which is 3 is to 1. So, empirical formula will become CH3, option number 3. 97. Question number, if mass percentage of glucose in aqueous solution is 36%, then the molality, small m it is asking, molarity is moles of glucose by mass of water. Mass of glucose is 36 gram and molar mass is 180, so mass of water will become 64, then molality will become how much? Molarity, it will 3.125, 3.125, option number 2. Question number 98. If 10 to the power 20 molecules of H2O are removed from 18 milligram of H2O, then moles of H2O left approximately. How many moles of H2O are left? The number of moles of H2SO4 remaining. Sorry, here it is H2. Number of moles of H2O remaining is 0.001 minus 0.0016. Okay, so for this we have to refer to as the detailed explanation. No, so we know that the molar mass of water is 18 milligram and the molar mass of water is 18 gram per mole. Molar mass of H2O. Okay, it is given, it is removed 18 milligram. Okay, and molar mass is, we know that it is 18 gram per mole. Now first we convert 18 milligram to 18 2 grams, which is 0.018 grams. Okay. Now 18 milligram of H2O will require 0.001 moles and 10 to the power 20 molecules of H2O will require this much moles. Now number of moles of H2SO4 remaining, it is 0.000883, which is 8.3 into 10 to the power minus 4 moles. Okay. Here it is also H2O. This is question number 98. Next question is Question number 99. If the mole fraction of urea in aqueous solution is 0.8, then the molality of urea will be. If mole fraction, molality we can calculate easily, which is 4.8 mole. Okay. Mole fraction, we know this formula. Mole fraction of solute, we know this formula. Now, moles of urea is 0.8, so mole fraction of water will be 0.92. And upon putting these values in the molality, we will find out that molality comes out to be 4.8. 4.8 is the correct answer. So, here or there, every other formula is related to every other question in this chapter. Okay. If you know some basics formula, you can easily calculate or you can easily solve for these numericals. 18.72 gram of substance occupies 1.81 centimeter cube. What is the density measured in correct significant figures? So density is mass by volume. It comes out to be 10.34. 10.34 is the correct option in correct significant figures. Okay. Yeah. So for this much is there for chemistry. Okay guys, keep learning. Thank you.